Hello everyone, we're going to review a little bit more at the beginning of class, and then I have a little activity that you can try at home with your families afterwards. All right, so let's take a look at the first question here. When I ask for you to determine the following permutations or combinations using the formula, if necessary, after you show all your steps, then you can use a calculator. But for right now, let's just kind of go through this. Now, obviously for A, we can't type that into the calculator with the N being there. But pause the video, go ahead and answer the first two questions, and we'll see what you're coming up with. Okay, pause the video if you need more time. So for the first one, we want to use the formula that we would have n factorial over r factorial, so that would become 0, and then times n minus r factorial. So we end up getting n factorial, 0 factorial is 1, and then we get this over n factorial, which is 1. So in the past, when we've been working with problems where combinations where we choose or we don't choose any from a certain set. So n choose 0 is always going to turn out to be 1. So if we have like 24 transistors and we're not choosing any, that would be 24 choose 0. And again, that would always just be a 1. Now for permutation, this is just n factorial, or in this case 8 factorial, over n minus r factorial, so 8 minus 5 factorial. So this would be the work I would be expecting to see. So we'd have 8 factorial over 3 factorial. And now this becomes 8 times 7 times 6 times 5 times 4. We could stop at the 3 because then that would divide out with the 3 factorial. Now obviously you could use a calculator for this, and we should be getting 6,720. All right, just like in the review, when I ask you what does n factorial mean, you don't actually have to write it out in words, just show a little bit of the process here of how to calculate. So we start with n, we multiply it by the number before it, and we keep going down a number all the way until we get to a times 1. All right, let's take a look at another example. So below is a summary of data for the 9th and 10th graders at a random high school. So go ahead and copy down the table or chart and answer these 3 questions. Be sure to pause the video. Okay, if you need more time, just pause the video again. If you're ready to see, check your work, just follow along. The first thing we do want to end up doing here is getting these totals. So we've got 95 total in choir. We have a total of 38 in band. For 9th grade, we have 75. And then for 10th grade, we have 58. Getting these totals either vertically or horizontally should give us 133. So the probability that a student selected at random is in the 9th grade or choir, well, how many students do we have in 9th grade? 75. How many students do we have in choir? 95. But we counted these 55 twice. So we would subtract the 55 and just keep it over 133. And go ahead and get that. And this gives us 115 out of 133. Now the probability that the student is in 9th grade and band, think of this as trying to get one card that has a couple things, that it could be a 6 and a spade. So we're just looking for that one amount. So this would just be 20 out of the 133. Now the third is the probability that they're in choir given that they are in 10th grade. So this is conditional probability of B given A has already happened. So given that they're already in 10th grade. So we could do this one of 2 ways. So how we could look at this is given that they are in 10th grade. So we just go to the 10th grade. There's only 58 students in 10th grade. And now we want the probability that they're in choir. So then that would be the 40 out of the 58. Or if you follow the formula for conditional probability. That's the probability of A and B divided by the probability of A. Well, the probability of A and B is the probability of 10th grade and choir. So if we go to 10th grade and choir, that's 40 out of 133. And the probability of A is just the probability that they're in the 10th grade. So that's 58 out of 133. And then we divide these. So this is 40 out of 133 divided by 58 out of 133, which becomes 40 out of 133 times 133 out of 58 still gives us 40 out of 58. So there's a couple ways to think of conditional probability. All right, pause the video again, copy this problem down and give it a try. If you need more time, pause the video again. So here's an example that it's like I'm making this up again just for some free samples. So we've seen this a couple of times previously. A restaurant has 7 offers for free samples. How many requests are possible if a customer can request up to 4 free samples? And again, they don't care the order they get this in. So we can have a combination. We have 7 offers and they get no free samples. We can have a combination of the 7 offers, they pick 1 free sample. Combination of 7 offers, they can get 2. 7 choose 3, and then 7 choose 4. Now that was up to. If it was an at least or an at most, you'd have to know how to read that as well. So this would be an at most. Now they could get 0 or 1 or 2. So because of the or, we're adding. Then of course you would use your calculator to get this. I just wanted to look at setting this up. A problem from the study guide I wanted to go over was number 40. And I just want to talk about this answer, or at least the way I have this set up. So the way I calculated this, let me just write this out first and I'll reread the problem. Because we're adding these results again. So this means that this first thing can happen, or the second thing can happen, or the third thing can happen. So this problem tells us that several territories and colonies today are still under the jurisdiction of another country. France holds the most with 16 territories. The United Kingdom has 15, United States has 14, and several other countries have territories as well. We're choosing 3 territories at random, so that's why we're adding these 3 together. What's the probability, again, that they're coming from France, United Kingdom, or in the United States? What is the probability that all 3 belong to the same country? So this first one is saying that they all come from France. So we have 16 from France, we're choosing 3. Out of the 45 altogether, we choose 3. Or they come from the UK, so the UK had 15, choose 3. Again, out of all 45, choose 3. Or they come from the US. So that's why we had to add them together, and the US had 14. So that's very similar to what we were doing up here. It was just probabilities, which is why we had to divide it by that denominator here. All right, so the activity we're going to take a look at, this is getting us ready for Chapter 5, which we will more than likely start on Friday. So what I want you guys to do, now this is an activity you're going to do with your family. I kind of call it like dice bingo. Maybe you can make a little fun wager out of this. We're going to use 10 zeros. You can make squares, triangles, any kind of shape. We want something that can cross out those, so that's why I don't use X's. You're just going to draw a number line, number it from 2 all the way up to 12, so just like this. And then you're just going to have 10 numbers. I'm just going to place them as zeros. Let me just fill this out all the way. So for instance, if I thought the majority of the results of rolling 2 dice would come out to 5. Like I would put 1 0 here. Maybe I thought the second one would come out here. I might put 4 zeros. So you just line them up this way. Maybe I think I'm going to get 2 results of 10. So you would just do this until you go through all 10 zeros. And then whoever is going to roll, you just cross it out. So if they roll a 5, a sum of 5, you would cross that out. If there was a roll of 10, you would cross that out. And you go until all your zeros are crossed out, and then you win the game. So it's kind of like dice bingo here. And we're going to do this in class. So the goal of the game is to be the first person to cross out all 10 of your zeros. So have fun with this. Let me know if you have any additional questions on this activity.